All right, in this video, we will be going over 7 through 13. Okay, who can tell me, how do I deal with a piecewise? Yep. You make your tables. Quickest, easiest way to do it. Some teachers have you graph and then erase. I think it's easier just to do a table. So I have to include 0. Even though it's not equal to 0, I have to include 0. And then this says less than, so I'm going to go with -1, -2. The opposite of 0 is? The opposite of -1? Opposite of -2? 2. I'm going to go ahead and plot that. 0, 0. It's going to be an open circle. -1, 1. And then -2, 2. So it is going like this. It is a linear function. Okay? The next one. Whoops, sorry, the pen went crazy on me. I must include 0. I must include 2. And a number in between is 1. 0 squared. 1 squared. 2 squared. Okay, so now I'm going to plot. 0, 0 is included in this one, so I'm going to fill the circle in. 1, 1, 2, 4. And because it's x squared, I know it's a parabola, so I'm going to put a curve. And then this is also a solid dot there. Okay, my final one is greater than 2. So like 2, 3, 4, and it's x. So my output is the same as my input. So 2, 2 gets an open circle. Then we have 3, 3, and we have 4, 4, and it goes like this. So this is the graph you should have. Okay? Good? It almost looks like an absolute value, except for this little curve kicked it out. Questions? All right, thank you. Number 8, okay? Circle the ones that are true. So it has a vertical asymptote of 1. Here's a vertical asymptote. Is it equal to 1? Yep, so true. That one is true. It is decreasing the whole time. That's going down, that's decreasing, so that is also true. The graph is decreasing the whole time. Okay? Erase this. Next, has removable discontinuity. No, what is another name for removable? Hole. I don't have a hole, so that is wrong. And has a horizontal asymptote at 2. Yes. Okay, question. Oh, that is wrong. That is wrong, because it should be a vertical asymptote at x equals 1. Good catch. So A is actually wrong. Vertical asymptotes are x equals, horizontal are y equals. Good catch. So you want to make sure that they're putting the right equation. The equation of this line is x equals 1. Good? So please watch for those little tricky things. I can't remember if that was a typo on my part or if you're supposed to watch out for tricky things. Okay, so 9 I did before, but I'm going to just go over it so we have it on a video. Nothing matches, and I can't factor, so I'm going to do crisscross. So I'm going to do x times x minus 4 plus 3x times x minus 2 all over x minus 2 times x minus 4. Don't forget to distribute to both parts. X squared minus 4x plus 3x squared minus 6x, which becomes what? When I simplify this, what does it become? 4x squared minus 10x all over x minus 2, x minus 4. Questions on that one? Okay? All right, this next one, this is factorable, so I have to factor it to see if I have a match. So I have x minus 4, x minus 3. I have a match. I am missing what? X minus 3. So the fraction that's missing it gets it in the numerator and the denominator because x minus 3 over x minus 3 is equivalent to 1, and when you multiply by 1, you're not changing the problem. So then that gives me 2x minus 6 minus x plus 2. Why is it a plus 2? Right, you have to, when it's subtraction, remember you have to distribute the negative to both parts. All of that over x minus 4 times x minus 3. 2x minus x is x. Negative 6 plus 2 is negative 4 over x minus 4, x minus 3. What do you notice? There's a hole, okay? There's a repeat. I can't leave the numerator empty, so I get 1 over x minus 3. Good? Okay. That's why it's important to leave the denominator in factor form so you catch things like that. Okay? Number 10. Okay. Remember, if it's less than, am I coming in from New York or California? New York or California? California. So this would be an exponent of a negative. This would have an exponent of positive. They want me to look at negative 1. So this is negative 1 from the left. This is negative 1 from the right. That might be very important for you to label that on your quiz so that you can answer the questions. Okay, so this first one, am I going to use the top or the bottom equation? The bottom, because it's from the right. Plus sign means from the right. From the right is greater than. So I'm going to use this equation. So I'm going to do negative 1 plus 1, which is 0. Okay, this one is from the left. So that's this top equation. So negative 1 cubed plus 1 is negative 1 plus 1, which is 0. Okay, so at negative 1, does the limit exist? It is 0 because they are in agreement. Does the function exist at negative 1? Why does it not exist? There is no equal to. Neither one of these has equal to. If one of them had equal to, then you could give a response. But in order to answer this, it has to be solid. It has to be included. Question. Why is the first one a negative exponent? Okay, so on a number line, where is less than? Okay, right? It is this way. This is the negative side. This is the positive side. So a negative exponent means from the left. This means from the right. Left is always less than. Right is always greater than. It has nothing to do with the sign in front of the number. It has to do with the exponent. So if I had said 2 plus, then I would still use this bottom equation. Why did I decide this is minus? Because less than. From the left. Because less than is the left-hand side of a number line. Greater than is the right-hand side. Less than left. They both begin with L. Good? All right. Moving on. Number 11. So this one you wanted to get out your handy-dandy graphing calculator. So let me go ahead and do that. So give me 1 second because I didn't pull it up ahead of time. And you have to be careful. If you have an older graphing calculator, because it's a fraction exponent, you need to put it in parentheses. If you have the newer ones, it gives you that little flashing box. Okay, but if you have like the 83s, you have to use parentheses. Okay, so I'm going to go to y equals. Let me clear what I already have. Can someone read the equation to me? Okay, so x, whoops. I have to do this. So x caret negative 4/5. So if you notice, this is a newer one, so it gave me the little box. And now I'm going to hit graph. Okay, here we go. So that's my picture, yes? All right. So let me quickly go back here. So it was something like this, yes? I know that's not perfect, but that's what it looks like, yes? So when I head out to negative infinity, where is my height going towards? 0. As I head to negative infinity, my height is heading towards 0. As I head to positive infinity, where's my y value, my height? 0. So both positive infinity and negative infinity head to 0 for this particular one. So end behavior is asking about your output. So as I put in smaller and smaller negative numbers, my graph goes closer and closer to 0. Okay? So it's asking about the height of, where does the height of the graph go? All right, the next one you can either enter as the square root of x or x to the 1/2. So clear. How do you want me to do? Square root or 1/2? 1/2, okay. So x to the 1 divided by 2. Hit graph. Okay. All right, so as I head towards negative infinity, my graph, what happens with my graph? It does not exist because why? Nope, give me a better answer. Don't tell me it starts at 0. There's an asymptote at 0. Give me a better reason. For why this does not exist. Okay, remember x to the 1/2 is the same as the square root of x. You cannot take the square root of a negative number. Thank you. As I head towards infinity, what happens to my graph? It goes to infinity. Excellent job. Okay, last question, which I already went over, but I'm going to do again. First thing I need to do is factor the denominator. So that's going to give me a over plus b over. So this is x plus 7, x minus 2, yes? Crisscross. So 3x plus 3 equals a times x minus 2 plus b times x plus 7. What is my first 0? 2. It's going to be positive 2. So this gets a 2, this gets a 2, this gets a 2. What's 3 times 2? Plus 3. 9. My a does what? Cancels. And I have 9b, which means b is worth 1. Yes, crisscross. Now I'm going to come back, and instead of using 2, I'm going to use what value? Negative 7 for all of the x's. So that gives me negative 21 plus 3, which is negative 18, equals negative 9a, making a worth 2. Problem done. I am perfectly fine with you just canceling them out. Yes. It doesn't matter which one. I could have had x minus 2 here and x plus 7 here. What just matters is that the 2 is with the 7 and the 1. Cool? Because we're not always going to factor. We're going to get the same 2 factors, but you might have seen the minus 2 before you saw the plus 7. Okay. Good? All right. That is all of the review. Okay, go ahead and clear your desk.